Hello, my name is Grace Truex, representing Team 1, not Iceland, for the ME 2110 final presentation. Here is the table of contents of what I'm going to be going over in this presentation, so let's get right on into it. Here is our problem statement. We need to create an autonomous automated system that starts, completes 2 specified tasks, archery and basketball, and an optional bonus task, Moneyball, then returns back to start where it completely turns off. Here is our HOQ showing our customer needs and engineering requirements, the most important ones being that the robot fits into the dimensions, that it's non-destructive to the playing field, it's within budget bounds, and is autonomous, because if any of that's wrong, it will get disqualified, and consistent performance, adequate archery system, and adequate basketball system, because that's how it actually scores the points. Associated with these are the engineering requirements such as size, runtime, launch accuracy and precision, and movement accuracy and precision. This is the specification sheet. Some of the more important ones are that width and length are only 18 inches instead of the maximum 20, so that we can have some leeway if things are hanging over the edge. We also want 100% arrow firing accuracy and basketball accuracy, but we know that that is probably not going to be possible, which is why they are wants and not demands. Of course, we want a no fire hazard and for the cost to be less than $100. This is the function tree that we created. The main function is to score points. There are 3 sub-functions of that, do archery, do basketball, and get the money ball. And with each of those, they have 2 sub-functions, launch ball, aim for target, move, place ball, grab the money ball, and adjust for the money ball location. Our morphological chart shows some conceptual designs because we have solutions to each of the functions and a strengths and weaknesses list associated with each of them. For example, the pneumatic air push for launching the ball has the strength of large projectile range, but a weakness is of inconsistency due to tank pressure. Using the morphological chart, we were able to come up with some design alternatives. Here is the first one, and the most important thing is that it is completely static. It has 4 mouse traps that launch the balls, 2 for archery and 2 for basketball, then a rack and pinion system that extends out the extension arm and grabs the money ball using a PC fan, and then reverses the fan to blow it back out. For design alternative 2, what's interesting about this is that it only has one launching mechanism using a pneumatic actuator air push. It has 4 balls loaded into the kind of canister, and it shoots out 2 for archery, then turns around and shoots out 2 for basketball. Then it uses the wheels to go and get the money ball and drop it into the basketball cups using a grabbing arm. For design alternative 3, it uses a scooper and slide to get the money ball and then drop the money ball and basketballs into the actual basketball container. And then it uses a pneumatic actuator push, not an air push, to get the archery balls into the archery cups. This also has a movement system to go close to the basketballs and drop the balls inside. Finally, we have design alternative 4. It uses a catapult actuated by a solenoid for the archery and a slide actuated by a solenoid as well for the basketball. The robot will move forward and stop when the IR sensor tells it to and release the basketballs to slide into the cups. What is most interesting about this is that there is no money ball associated with this because we wanted only to focus on the tasks that are required. We then put each of the concepts into an evaluation matrix and compared them against some customer needs, the most important ones being that the robot fits the dimension constraints, non-destructive, within the budget bounds, and is autonomous. And we found that concept 1 would best fit our needs. This is our Sprint 1 design. You can see in the bottom left corner that we have the CAD for it. You can see the 4 mouse traps on top with the angle adjustment arms attached with each. And in the bottom right of that, you can see the ball holder that would go onto each of the mouse traps that actually holds the balls to launch them. And then you also see the rack and pinion system with the PC fan and vacuum attached to it. Then we found out that that was an illegal design, so we had to change some things when we actually fabricated our robot. Main thing was that it no longer was a static system and has a movement system, as you can see with the motor and motor mount, the axle, the gear, and the wheels down here. We had to move the motor from being used for the extension arm to be used to set off the archery and basketball mouse traps. Therefore, we were not able to complete the Moneyball system because there was no way for it to extract and return in time. So we just did not do it because it was bonus. Then for the catapults, they are on two different levels so that the ball holders do not hit each other. The string is attached to these blocks that hold the ball holders back in place. When the motor rotates, it pulls the strings, pulling the blocks out so that the catapults actually release and throw the basketball and archery. Luckily, we were able to score full points for sprint 1. We were able to successfully start and return. One of the requirements was to get 2 archery balls in red colored containers, and although we didn't actually get them into red, we mostly got rim shots. It still counted. And for the 2 basketballs, we had to get past the scoring line, which we did do, and once again, were mostly rim shots. Downside was that there was no working money ball system for this, and we wanted to increase our accuracy for both basketball and archery. In order to improve upon our design, we definitely knew that we didn't want to use string anymore. So we decided to set off the archery system using a solenoid. That freed up a motor to be used for the rack and pinion system, which now we could attach the money ball and basketball system onto. The basketballs are stored in the white tube being held up by the solenoid. The robot moves towards the basketballs, picks up the money ball using the money ball grabber. Then the drawer side extends over the cups. The solenoid pulls back, dropping the basketballs over and hitting the money ball, and all 3 go into cup, and then it rolls back to start. As you can see, archery is also slightly different. Instead of having 2 separate catapults, there is now just 1 catapult with a ball holder that holds 2 balls instead of just 1. And we believe that that would be easier because that requires only 1 angle adjustment instead of the previous 2 angle adjustments. And our Sprint 2 results were also very promising. We were able to receive full points with a successful start and return for all except for the last one, where the return went a little bit too far. Our archery would get 1 ball into the orange consistently, while the other would rim shot. The basketballs would mostly go into green, except for when the solenoid misfired on the last round, getting into, I believe, yellow. And a slight bonus was that we got the money ball to work for one of the rounds. Of course, we want to improve all of this for the final competition, getting in both archery balls into cups, getting the basketballs into only greens, and having the money ball work for each round. Our final design is basically the same as Sprint 2, except now the archery catapult is on a wedge, allowing for the shot to be more of a lob instead of a rocket shot towards the balls. And hopefully this arc will allow us to get more balls into the cups instead of just getting rim shots. This is the bill of materials for our final design, and as you can see, the $36 total cost is way less than our maximum budget. This is because the majority of our robot is made out of MDF, which was the most cost, being only $15, and then the second most expensive was the drawer slide, which was only $7. Our predicted results for this final competition is that we get a minimum of 1,220 points. That is 370 points per trial. 10 for start, 100 for archery, considering 40 for a rim shot and 60 for getting 1 into orange. 220 for basketball, both balls getting into green. 20 for return, and at least 1 round where the money ball gets into the green cup. And this is our robot in action.